Here we are. We are at the last lesson of trigonometry for this course. It says review from last class, but it's actually the review from the last two classes, or I guess last two lessons, one of which was the solving linear trig equations that was likely an independent study lesson, and then the factoring lesson that I did with you. So I'm going to move question C to another page because it looks like a biggie, both in size and in difficulty. Remember that when we do get to C, that all of these three questions, you're expected to answer one rotation of the unit circle, so one time around, and also make sure your answers are in radians. So when C disappears, the rules still apply for it. I hope I made B movable. Oh yes, I did. I'm so smart. I'll come back and take a look at this in a minute. We'll look at this one first. So you do still have an option of turning cotangent x into an m. If you do that, you can't just do it arbitrarily. You have to actually communicate your intentions. And then you can treat this like a grade 9 question where the 4 will have to change operations. And we will also have to divide by 3 on both sides. And then if you realize that that answer is -2, actually let me change this color combination to black. If you realize that -2/3 is the fraction sitting on the right hand side and that m is now sitting alone, you can transfer that back to cotangent x. Hopefully you remember from that independent study lesson, or otherwise if you didn't do it by independent study, that cotangent isn't a button on your calculator, so you are allowed to flip to its reciprocal identity, and then that is tan x. But if you flip the left hand side, you have to flip the right hand side, and that is not a number from the unit circle, so we're going to have to dig out the cast rule. So C in the fourth quadrant, A in the first quadrant, S in the second quadrant, T in the third quadrant, and this says that tan has a negative ratio, so that means it can't be in the all positive quadrant and it can't be in the tan positive quadrant. It has to be in the other two, and we're talking about finding an angle that fits in there. And to pull that off, you do second function tan of 3/2 without the negative. So calculator time. Can't do that in our heads. Again, my calculator might work a little bit different than yours. So 3 divided by 2 is this decimal. And then axis trig, and we'll do second function tan. And to one decimal place, the number of degrees is 56.3. So that's not an answer because it's not in the all positive quadrant. That is the space of the little x's. So to figure out the rotations, that one will be 180 minus 56.3 degrees. And this one will be 360 minus 56.3 degrees. So I'm going to come up with a therefore statement now for x. Oh good, my calculator is there. So 180 minus 56.3 degrees is 123.7 degrees. But we don't want our answers in degrees. We want our answers in radians. So I'm going to do that quick little calculation on the calculator. So that's times pi divided by 180. And that turns out to be 2.16 radians for that smaller rotation. go through the same process, different numbers. 360 minus 56.3. That's 303.7 degrees. I need it in radians, so times pi divided by 180 is equal to 5.30. So we have a good idea that these are the right answers, because if you think about it, 2 pi is 2 times 3.14, which is 6.28, and I haven't gone over 6.28, so that's good news. So this was not a unit circle question, and it was a linear question. Let's move on to this. A reminder, at the very end, we need to make sure that we have our answers in radians. And because it is all the ratio cos, I'm going to let m replace all the cos x's. You can't use x, because then you would be saying let x represent cos x, which is kind of illegal because you have a different letter. So m squared minus m equals 0. And I hope that you can see more clearly, or equally as clearly to the beginning line, that this is a common factoring question. So we can take out an m from each, leaving 1 behind and none behind. M equals 0. Let's go back to the old school color coding. M equals 0. M minus 1 equals 0. M was cos x, so I'm looking at cos x is equal to 0, and cos x is equal to 1. And both of these are on the unit circle. So I'm going to find all the values on the unit circle, and these will be pretty radian answers. All the values on the unit circle where cos x is equal to 0. So that's the first coordinate is equal to 0. So there's one. And there's one. No other places. So I can write 3 pi over 2 radians and also pi over 2 radians. So pi over 2 radians and 3 pi over 2 radians. Now I go to the other half of the question. The cos x is equal to 1. So I have to find all the places on my unit circle where cos x, the first one, is equal to 1. So that's here. And remember, when you are at the 3 o'clock mark, you have to answer with both radians. That's why I was so specific about making sure you had this kind of unit circle. So 0 and 2 pi. I will add 0 radians and 2 pi radians to the answer, and we're done that one. I quite like unit circle questions more than cast rule questions because I find them quicker to take care of. So the last question before we tackle something new is question C. And the problem with question C that we haven't run into before is it's not consistent, the length of the question, with respect to the fact that you've got 2 trig ratios. You've got a cos squared x and a sine x. And there's no way to turn a sine x into a cos x, but there is a way to take cos x or cos squared x and turn it into a sine squared x by using Pythagorean identities. So I'm going to write down the 2 again, and then I'm going to put a bracket down plus sine x. I'm going to pull the 2 over from the other side, equals 0. And in that bracket, I will put the replacement for cos squared x. Check your identity sheet if you are not quite sure where this is coming from. We have that. So now I'm going to multiply out the bracket. So 2 minus 2 sine squared x plus sine x minus 2 equals 0. 2 minus 2 is 0, so I'm not going to write that down. And what's left is that. And that is another common factoring question because I've got no other terms and I've got a sine x in both terms. So I'm going to take out a sine x. Yes, you could take out a negative sine x if you wanted to. I'm leaving behind negative 2, a single sine x, plus 1 equals 0. If at any time you wanted to take your sine x's and turn it into m's to maybe see it better, you are more than welcome to do that. I'm going to keep going, dig out the green pen. So sine x is equal to 0. Negative 2 sine x plus 1 is equal to 0. Take the 1 across the equal sign and reverse its operation. Divide both sides by negative 2. And we end up with sine x is equal to 0 and sine x is equal to negative 1 over negative 2 is positive 1 over positive 2. And I'm pretty excited right now, whether you can tell in my voice or not. These are both unit circle measurements. There, that's exciting. So I don't have to dig out the cast rule. I just have to answer in radians all the places where sine x, the second coordinate, is equal to 0. So all those places are, here's where sine x is equal to 0, so we have to list those answers. There's another one over here, so I have to list that answer. So 0, pi, 2 pi, if I feel like putting them in order. So 0 radians, pi radians, 2 pi radians. And then I can resume the search for the second value. So sine x is equal to a half. So I have to go back to my unit circle and find all the places where sine, the second one, is equal to a half. So I get to also list pi over 6 radians and 5 pi over 6 radians. Remember, negative a half is not good enough. So pi over 6, 5 pi over 6. And that is all. So I'm going to take a little hand break right now because I'm cramping up, and we're going to look at these questions shortly. Or at least I'm going to look at them shortly. You can pause whenever you like. So before I start, this is not a good situation. So we got to make some changes that way. So I'll be back in a sec. Okay, a little longer than I expected. Let's erase some of this stuff and we'll get at her. So these are double angles. It also applies for more than double angles. So that's why I've titled it double angles or more. So if this was a triple angle or something even higher than that, you would deal with it the same way. So I need to take a minute to unlock this and move this out so I have a lot of space to play with question A. Let's lock that in so it's not movable. Alright, so there is an inconsistency in this question, as with all double angle or more questions, and that is that this does not match this. So you've got to make it match. And it's really quite simple to make it match. All you do is you multiply by whatever you need to. So for me, I have to multiply this by 2, this by 2, and this by 2. Why 2? Well, because I need a 2. So that changes the rotation to this. Now we're doing this entire question in degrees, so I have to make sure in the end that all my answers for 2x's go twice around the circle. And when I get my answer for x, which is actually what I'm looking for, I have to make sure that all my answers are between 0 and 360 degrees. So you treat this just like normal. The unfortunate part about this question is this question uses the cast rule because we don't see a quarter anywhere on the unit circle for cos. So I'm going to dig out the cast rule here. So C, A, S, T. And just like normal, so you start just like normal, you figure out where cos is allowed to have a positive ratio. So that would be in the all positive and in the cos positive. And then you keep going like normal. So RAA is equal to cos inverse of 1 over 4. And you dig out your calculator and you get a number of degrees. And you're well on your way at this point. So 1 divided by 4 equals, knew that, second function cos, and we get 75.5 degrees. Now, although I've called that an RAA, it's not always one of your answers. In this case, it really is one of your answers because that's the rotation here. Now, you have to really pay attention to what I'm doing here. So I'm actually going to draw a second cast rule that is identical to the first one. And I'll show you why in a sec. I'm going to put this one here. The first thing you have to do is you have to figure out this rotation, which, no problem, 75.5 degrees. And you have to figure out this rotation, which is 360 minus 75.5 degrees. So I'm just going to figure that out quickly. 360 minus 75.5 degrees, and we end up with 284.5 degrees. I'm going to, even though normally I won't scribble this answer here and I'll just put it in a therefore statement, I am actually going to do that right now. So 284.5 degrees. Yep. So the problem is, this is one rotation. This is 0 to 360. My space is 0 to 720. So I need to do this and find that out. And to be perfectly honest, and I hate to scribble all over the place, but I think this is effective, to get from there to there, you just add on an extra 360 degrees because it's the same space but 360 degrees later. So I'm going to do that now. 75.5 plus 360 is equal to 435.5. For 35.5 degrees. And then this rotation, follow this, once all the way around, and then to the exact same measurement that is. So all you have to do to get from this answer to this answer is, again, add 360 degrees. So 284.5, add 360, is 644.5. So now that we've gone 2 rotations, because that's what this says, we can write down our answers, all 4 of these. The problem is, these answers are not for x. These answers are for 2x. So 75.5 degrees and 284.5 degrees and 435.5 degrees and 644.5 degrees, which means we aren't done because the question said solve for x. So if I have to solve for x, That means to get from this line right here that I've got to my final answer, I have to divide by the number in front of x, which in this case is a 2. So I have to take every single one of these answers and divide them by 2. And I'm going to answer to 1 decimal place each time. I have my cell phone here, so I'm not going to show you the actual dividing by 2. You should be able to not see it and get an answer just fine. So the first one to 1 decimal place will be 38, nope, 37.75, so 8 degrees. Next one, 284.5 divided by 2. 142.3 degrees. 435.5 divided by 2. 217.8 degrees. And 644.5 divided by 2 is 322.3 degrees. And as promised, every single one of those answers for x are between 0 degrees and 360 degrees. So if you take 37.8, although it's rounded, if you doubled it and hit your cos button, you would end up with approximately 0.25. If you did that with 142.3, doubled it, hit the cos button, you would approximately end up with this. Same with 217.8, same with 322.3. Any other number will not give you close to 0.25. And the reason I say approximately is because each one of these was rounded, and then we rounded this, which is why radians are better than degrees. They're far more accurate. So we're going to do the second question here. So this one. And we're going to do the same thing, only I bumped it up a notch. We're still going to take care of x being between 0 and 360 though. So let's put that there. And you can take care of this using m. I'm going to not do that. I'm going to take the 3 across the equal sign and change its operation. Divide by 4, divide by 4, and we end up with cos 2x is equal to 3 over 4. And remember, we want x to be between 0 and 360 degrees, according to the question, which means that 2x is between 0 times 2 and 360 times 2. So again, 2 rotations. The unfortunate part is this is another casserole question, so it's not a unit circle question because you don't recognize that number, hopefully. So here we go again. And this time I'm going to show you how to save some button clicks on the calculator. So cos, positive value. So what I need to pull off is RAA is equal to cos inverse of positive 3 over 4, always positive. That rule is still in play. So 3 divided by 4 equals that decimal. Second function, cos, 41.4 degrees. So I am going to make a list for 2x as I go. So this one is 41.4 degrees. This one will be 360 minus 41.4. So 41.4 degrees. I'm going to give you my big therefore. While I've got 41.4 in my head, I'm going to divide it by 2 because of the big 2 out front, and we get 20.7 degrees. I'm going to figure this one out. 360 minus 41.4 is 318.6. And while that's on my calculator, I'm going to divide it by 2. So that's 159.3 degrees. Then, I know that I'm just gaining an extra rotation, so I'm going to take 41.4. I'm going to add 360 degrees to it, so I get an extra rotation, because I need 2 of them. You can add or subtract as many as you want. The deal is you have to keep your 2x in between 0 and 720. So if I add another 360 to that, it's 761.4, so I'm out of bounds, so I'm not allowed to write down that answer. While that 401.4 is on my calculator, I'm going to divide by 2 and get my final x answer, which is 200.7 degrees. And then finally, I'm going to take 318.6, add 360, I get 678.6, so still within 720. And remember, all these ones on the left are your 2x answers. You need to divide them by 2 to get your 1x or x answers. And this is your list of values that are trapped between 0 and 360. If you had made a mistake and gone over here, you would go over here and just not list it, or list it and then scribble it out, or erase it, whatever the case is. So here is your last question. There it is. And I'm messing with you. This is not normal. Another thing that's not normal is that. So what are we going to do this time? We're going to times by 3. So 180 times 3 is 540. So 3x, so that's 540 and negative 540 degrees. So let's take care of this with an m temporarily. And remember, what this means is we really got to focus on the space. This is a difference of squares. Whew, factoring. And I'm going to dig out the green pen. m equals negative 1, divide by 2, divide by 2, and I get sine 3x is equal to negative 1/2. Over here, 2m is equal to 1, divide by 2, divide by 2. There's the Harley. Sine 3x is equal to positive 1/2. Are you excited? These are unit circle measurements. That still doesn't mean you should get cocky. Let's list our 3x answers. So, we have to look for all the places where sine x, even though it's a 3, We have to look for all the places where sine x is equal to -1/2 or +1/2. So we can do this search pretty much at the same time because the values are the same. So let me just get my scribbles out of here from the last one and find all the places where sine, the second one, is 1/2 or -1/2. So there's 1/2, there's 1/2, there's a -1/2, there's a -1/2. So we have an answer of 30 degrees, of 150 degrees, of 210 degrees, and 330. So let's see if I can remember them or flop back and forth. So 30, 150. 30, 150, 210, 330. 210, 330. So you can take any of these values and add or subtract a rotation on as long as the numbers result between 540 and -540. So I'm going to dig out the calculator just because I don't want to think this through too badly, and I'm going to let the technology do the work for me. And I want you to see this. Oh, not quite that big. Ah. Okay. So, I'm going to take 30 degrees, input it into the calculator, and I'm going to add 360. If I hit equals and it's under 540, I have to write it down. I have to write it down. Then, while I'm still dealing with it, I'm going to add another 360. Too big. I'm going to start with 30 again, and I am going to subtract 360. And as long as I'm still within -540, I'm okay. So I have to write that down. And then while that's on the calculator, I'm going to subtract off another 360, another rotation. Too big, negative. Now I'm going to do the same thing with 150. So 150 plus another rotation. Still good. While that's on my calculator, add 360. See, I didn't even think about it. Yeah, that's outside. Start with 150, subtract 360. Yep, I'm good. Subtract another 360. Too big on the negative side. Now I get to do it all with 210. So 210, add a rotation. No. 210, subtract a rotation. -150. That'll work. While that's on my calculator, minus another rotation. Hey, that still works. While that's on my calculator, subtract another rotation. No, and I should have known that. Last one is 330. So if we take 330, input it into the calculator, add a rotation. No, too big. $330, subtract a rotation. Yeah, I get to write that down. And, oh, damn. Negative 30, subtract 360. Negative 390. Subtract another 360. Nope, too big in the negative side. So these are not your answers. Do you remember why? It's because we are looking for x, not an answer for 3x. So if this was a 2x, like the last two questions, your job is to divide by 2. It is not a 2, it's a 3. So you get to take all these answers and divide by 3. I just hope that sometimes you're aware of where you can cut down some work. So by that, I mean, here, I've got a 30 and I've got a negative 30. And I can divide both of them by 3 and get an answer for x that is positive and negative 10. Here's a 150, and there's also a negative 150. Divide by 3 will give plus and minus 50. Here is a plus and minus 210. Divide by 3, that'll give you a plus and minus 70. And this doesn't always happen, but you have to recognize it could happen. Divide by 3. Negative 130 degrees, positive and negative 130. And then finally I've got my 5 tens, both positive and negative. I could do this in my head, but I'm feeling a little rusty. Oh, my calculator's not even working. 170 degrees. All your answers are in degrees. All the answers are trapped between positive and negative 180 degrees. Every single one of them. And yeah, there's a lot in this question. So you have to make sure that you follow the rules of the question to get them all down. So, as I said off the top, this is the end of the road for trig. I don't know that these numbers are right. Please check the Google site and you'll be able to check them out. But that is it for trig. Say goodbye, except for your exam, to your unit circle. But remember, it may come up in your life if you continue to do math. Get that out of there. Anyways, hey, that's not so bad. Bye.